I'm going to introduce you to the concept of radical expressions. So we'll start with the radicals that we know. So for example, square root of 9. Most people know, having seen this before, that square root of 9 is 3. We know this is true, and the reason is because 3 times 3 equals 9, or we could say 3 squared equals 9. Similarly, if I say square root of 25, we know that this is 5, and the reason is, again, because 5 times 5 is 25. My idea of radicals is, let's think of square root. The square root sign is like jail. And when you're dealing with square roots, it takes 2 of them to break out of jail. So if we're looking at square root of 9, the way we'll work this is we'll say, let's get the prime factors of 9, which we know are 3 times 3. And the idea is that the square root is like jail, and for every pair under jail, they break out and you're left with 1. So these two, out of these two, one breaks out, they break out, and you're left with 1. And I originally came up with this idea of jail because my son used to like to watch Transformers, that program. So this is almost like a transformation. They break out of jail, they transform, and out comes, for every pair, out comes 1. So the key to doing this is square root of 25 is we will get the prime factors, in this case of 25, which are 5 times 5. And so now, as I mentioned, it's like the transformation. These whoosh, for each pair, out comes 1. So your answer is 5. Let's try another one. Let's do one you know the answer to, like square root of 36. My technique involves getting the prime factors of 36. So to do that, I have 36. So I get the prime factors. 2 goes into that 18. 2 goes into that 9. We can't use the prime number 2, so we use 3. 3 goes into that 3. 3 goes into that 1. I've now got the prime factors, and I put those underneath. We have 2 times 2 times 3 times 3. So now my idea of jail, for every pair, out comes 1. So out of these pair, out comes 1 2. Out of these 2 3s, out comes a 3. So sure enough, square root of 36 is 1 2, 1 3. 2 times 3 is 6. So for every pair, it takes a pair to break out of the square root. Think of it as square root jail. So the approach for this, the square root, as I said, it's like square root jail, which means for every pair, it takes a pair to break out and you get 1. It transforms to 1. So now suppose I said, what is the square root of 144? To work this, it's all going to hinge on getting the prime factors of 144. So working that to get the square root of 144, the prime factors, we start with 2. 2 goes into that 72. 2 goes into that 36. 2 goes into that 18. 2 goes into that 9. We're now ready to not use 2. The next prime that works is 3. 3 goes into that 3. 3 goes into that 1. We now have the prime factors of square root of 144. So we see we've got 1, 2, 3, 4 2s, 2 times 2 times 2, and then we've got 2 3s, 3, 3. So now I've got one pair of 2s, out comes a 2. From this pair, out comes another 2. From this pair, out comes a 3. So a square root of 144 is 2 times 2, 4 times 3 is 12. And that's basically what we expected, because we know that 12 times 12, or 12 squared, is 144. So this concept of jail, square root is square root jail. It takes pairs to break out. So now we're going to let's look at cube root. Looking at the concept of cube root of 8. Well, cube root is also jail, only it's a stronger jail. So in order to break out of cube roots, you have to have, instead of pairs for square roots, you're going to have triples. So we put the prime factors of 8. So it's cube root of 8 is 2 times 2 times 2. And now, because this is stronger jail, it takes a triple to break out. Out comes 1, 2. They break out and transform into that 1, 2. And that's your answer. Suppose I have you try and simplify cube root of 343. All of this is now based on getting the prime factors. So for 343, we have to think what prime number divides evenly. So 2 doesn't work. We look at 3. 3 doesn't work. 5 is the next prime. That doesn't work. So now we go to 7. And 7 goes into 34 4 times, 28, with 6 left over. 7 into 63, 49. And now we continue with that prime. 7 goes into 49, 7. 7 goes into 7, 1. We now can write cube root of 343 as cube root of 7 times 7 times 7. So this is a strong jail. It takes 3 of them to break out, and you get 1, 7. So the cube root of 343 is 7. Let's try another one. Let's look at the fourth root of 625. So again, following in the same pattern, this is a stronger jail. We have to get the prime factors of 625. So the prime factors of 625, 2 doesn't work, 3 doesn't divide evenly, so I go to the next prime that works, which is 5. 5 gives me 1, carry a 1, 2, carry a 2, 125. Now I work with 5. 5 goes into that 25. 5 goes into 25, 5. And 5 goes into 5 once. Once you've got the 1, you've got all the prime factors. And sure enough, 625 is 5 times 5 times 5 times 5. We've done that 4 times. So this is a stronger jail. Instead of a pair to come out or a triple, we need a quartet to come out. So you need 4 of them, so the answer is 5. We're now going to expand this not only with numbers, but you're also going to have variables. So for example, suppose I ask you, and I want you, the explanation is we say we simplify. So suppose I want you to simplify the square root of 81 x to the 4th y to the 6th. Okay, again, now in this case it's square root, so it's going to take pairs to break out of jail. First step is we're going to put the prime factors for this expression under the square root. So I'm going to get the prime factors of 81. Prime factors of 81. 2 doesn't work, but 3 does, gives me 27. 3 goes into that 9. 3 goes into that 3. 3 goes into that 1. We've got the numbers. So in here, I'm going to put all the prime factors. So I have 1, 2, 3, 4 3's being multiplied. I have 4 x's being multiplied. And now y to the 6 are 6 y's all being multiplied. Since this is square root jail, it takes pairs to break out. So we have 1 pair of 3's. There's a 3. It transforms to 1, 3. 1 pair breaks out, becomes a 3. You've got 1 pair of x's. Then you've got another pair of x's. Then you've got 1 pair of y's, another pair of y's, and then finally a third pair of y's. So this just becomes 9x squared y cubed. That's the simplified version. Another example, I might say simplify the cube root of 125 x to the 6th y to the 3rd. So for this, I'm going to rewrite it. I know that 125, if I get the prime factors, 5 gives me 25, 5 gives me 5, 5 gives me 1. So I can say this is the cube root of, I'm going to have 5 times 5 times 5. X to the 6 are 6 x's being multiplied. 5, 6. Y cubed is 3 y's being multiplied. Because it's cube root, it's a stronger jail, so it takes 3 of them to break out. So you have 1, 5. Then we have, for these triple of x's, we have 1x. We have another x, and then we have a y. So the final result, having simplified this, is 5x squared y. That's the cube root of 125. X to the 6 y cubed. Once we see this concept, these worked out very nicely because 125 was a perfect cube, and x to the 6, you could get triples out of 6 of those in y cubed. But let's take a look. We're going to extend this to further simplification. I'll go to the next page. So here's one that looks at first a little surprising. I want you to simplify the square root of 63 x to the 5th y cubed. Many of us know that square root of 63 is not a perfect square. We know that 63, that is not a perfect square. But we're going to use the same idea of factors and pairs to actually simplify it. First step is we're going to get the factors of 63. So we start with the first prime number, 2 does not work. So then we go to the next. 3 goes into that, 21. And we continue with it till it doesn't work. 3 goes into 21, 7. And then we can see, oh, now we have 7. That's our next prime. We now have the prime factors of 63. I am now going to write this. This is now square root of 63 is 3 times 3 times 7. We have x to the 5th, so we have 5 x's being multiplied. And we have y cubed. We have 3 y's being multiplied. So now what comes out of jail, for each pair they break out of jail, you have a 3, you have an x, you have another x, and you've got a y. However, what's stuck under jail that isn't paired has to stay there. They didn't have enough power to break out of jail. So left under jail is a 7, an x, and a y. So they stay under jail. So simplified, the square root of 63 x to the 5th y cubed becomes 3x squared y. They had broken out, and then times radical 7xy. What you have is what's outside of jail and what's inside. And this is going to be important because expressions outside of jail can multiply and expressions inside can, but you can't mix the two. We'll try another one. Suppose I ask you to simplify the cube root of 54 x to the 5th y to the 4th. Again, hopefully everyone recognizes this will all hinge on the prime factors. I'm going to get the prime factors of 54. So I start with the first prime, 2. 2 goes into that 27. 2 doesn't work anymore. Then I go 3. 3 goes into that 9. 3 goes into that 3. 3 goes into that 1. Those are the prime factors of the numbers. So now I want the cube root of, I have a 2, I have 3 3's, I've got x to the fifth, which is 5x's being multiplied. Y to the fourth is 4y's being multiplied. And I'm now ready to do the break out of jail. This is cube root jail, so it takes triplets. So now the triples break out of jail. So out comes a 3, out comes an x, out comes a y. But I do have terms stuck under the radical in jail. So I then have cube root of what is left under is a 2, x times x is an x squared, and a y. So simplified, this becomes 3xy times the cube root of 2x squared y. It's important that you put the cube root there so we knew that it came from taking triples because it's different strength. It just